So now this brings us to why Euler's formula will be useful for us, is because now we can find roots of these complex numbers, which actually seems very complex. Because if I want to take the square root of 1 plus I root 3, that's the same thing as raising that complex number to 1/2, right? Remember that? If I want to take the third root, I'd raise it to the 1/3. Fourth root, I'd raise it to the 1/4. Well, if I just said this, well, that's just the square root of 1 plus I root 3. Doesn't really give me tons of information. So what I'm going to do is I'm going to take this complex number and kind of run down everything we've learned in this section. I'm going to go ahead and plot it just to give myself a visual. So I go over 1 and up root 3. And again, you can put the I after the radical or before. I usually write it before, but for some reason I wrote it after there. So if I go ahead and create a triangle, we know this value is 1, this is root 3. Well, what I want to do first is I want to write this in Euler's formula. So R e raised to the I times theta. So I need to find my R. Well, we have that here. So R squared equals 1 squared plus root 3 squared. So we get 1 squared, that becomes 4. And then if you take the square root, the thing becomes 2. Well, now if you find theta, remember it's inverse tangent of opposite over adjacent. And this is on your unit circle, and hopefully you're feeling better about that. Let me just go ahead and see if I can bring it up. Oh, I don't think it's going to come up. Well, if I do that on my unit circle, that value is 2 pi over, no, I'm so sorry, it's not 2 pi over 3, it's just pi over 3, because we're in the first quadrant. Okay, so we have our theta, we have our R. So now we're going to name this complex number Z, lack of creativity, 2e raised to the I times our theta, which is pi over 3. Okay, so what I want to do is I want to raise this to the 1/2 so I can find the square root. Well, knowing our properties of exponents, we get 2 raised to the 1/2. So I could write that as root 2. And then because this is e raised to all of the, I times pi over 3, remember properties of exponents, you can multiply those. So that becomes e raised to I pi over 6. So let me just rewrite this to be root 2 e I times pi over 6. Oh, sorry, my brain did not write 6. Okay, now, like everything in mathematics, we have to give our answer in the form it was originally given to us. So that is, remind ourselves that is actually known as rectangular form. So I need to write that in rectangular form. This is why we did so much going back between all those forms. So that means this is Z raised to the 1/2 equals, we have our R, and that's cosine. We have our theta plus I sine our theta. Here's the cool thing. You can use your unit circle. Well, we know cosine of pi over 6 is root 3 over 2 plus sine of pi over 6 is 1/2. And then if we distribute that, we end up getting root 6 over 2 plus I root 2 over 2. You can leave it like that, or you can put it over the same denominator. And that is the square root of 1 plus I root 3. And again, you'll start using this much more in another math class. We're just exposing you here. So now, example 4 said find a square root. So we found 1, right? Where example 5 says find 2 square roots. Well, remember that back in the day when we started learning math, if you saw the square root of 16 and it just said find this, you would just say 4. But when you personally write that square root symbol, we were taught, no, it's plus or minus 4. Because those square roots produce 2 roots, right? This is known as your principal root, just the positive one. Well, in example 4, we were finding the principal root. In example 5, I want to also find this negative value. So what we're going to do is, it's going to be the same process that we did before. So we're going to go ahead. We got to find our R. We got to find our theta. So again, I'm going to give myself a visual because it just helps. So this is -1 up root 3. So we're here. -1 up root 3. And we can find our R. So save us some time. We get R equals 2 because we did that work. It's similar to the one we just did. Well, now what is our theta? Well, inverse tangent of theta, forgive me, inverse tangent of, remember, theta's there, root 3 over -1, that equals your theta. So again, knowing that unit circle, okay, and we're going to say it's this angle, because if we use our calculator, it will give us, you know, because inverse tangent is only defined from here to here, but we really want this entire angle. And again, rely on your good old unit circle. Well, where that happens is 2 pi over 3. Okay, so what we end up getting is now we're going to go ahead and put that back into our beautiful form. And, okay, hold on. There we go. Okay, so if we go ahead and we'll put in Euler's form, Z equals 2e raised to the I 2 pi over 3. Once again, we want to take the square root, so we're going to raise it to the 1/2. So we end up getting 2 raised to the 1/2 e I. Well, if we do this, remember we multiply those things, we get 2 pi over 6. If we reduce that, we get, I just changed 2 raised to the 1/2 as root 2. We're going to get pi over 3i. Okay. So this is one root, but what we have to do again is change it back into rectangular since it originally was rectangular. So same process as we did in example 4. So we get root 2 cosine pi over 3 plus I sine pi over 3. Again, your unit circle is your best friend. Cosine of pi over 3 is 1/2. And sine of pi over 3 is root 3 over 2. Go ahead and distribute that. We'll end up getting root 2 over 2 plus I root 6 over 2. Okay, so same process. Nothing new from that last example. The issue is we also need another root, right? We want that plus or minus business. So how you find that other root is we use this angle now. Okay, so that angle, okay, is if we go from here to here, is going to be negative 4 pi over 3. Same process, but now we're going to use this theta. So let me change colors so it stands out a little bit more. So I'm going to cut that off. Okay, so we have z, another half or square root would be root 2, because we already found our r, e raised to I times negative 4 pi over 3. Okay, I want to raise this to the 1/2. Oh, sorry, my 2 is just a 2, not root 2. My r is just 2. Then I distribute that exponent and we get I. This will become negative 4 pi over 6. I'm going to rewrite that as root 2 e. Okay, well, I can reduce that, and that ends up becoming negative 2 pi over 3 when I reduce it. And so we're going to do the same process because I want to write it in rectangular form. So z raised to the 1/2 is going to be root 2 cosine negative 2 pi over 3 plus I sine negative 2 pi over 3. Using that beautiful unit circle, we got root 2. Well, cosine of negative 2 pi over 3 is negative 1/2. And then we have sine of negative 2 pi over 3 is negative root 3 over 2. And again, you can write the I before or after. So I'm consistent. I usually write mine before. And then I distribute. So I get negative root 2 over 2 minus I root 6 over 2. So that will give me the other root, like that plus or minus business. Now to know which one is your principal roots, okay, here's the key thing. Your principal root your angle is always between negative pi to pi. So what the heck does that mean? So you go from negative pi, So from negative pi to pi. So your angle has to live there. So we have two angles, right? We have the negative 4 pi over 3, which that put us outside. I'm going to use a different color. That put us here. So it went outside of this range. So we would use the 2 pi over 3, remember, going this way because it keeps us inside that range. So this is our principal root. Okay. As for example 6, I'm going to have you all try it on your own. So once again, what this is saying is, it's the same thing as saying if you raise this. So if I take this complex number, and here I'm writing the I after, just so you get comfortable with it either way. That's the same thing as what the cube root of that is. So I just want you to find 1, okay? Because again, remember the cube root of 8 is just 2. So we don't have to worry about multiple roots. So you're going to do the same process, right? You got to write it in Euler's formula, raise it to the 1/3, figure out your R, your theta, and then rewrite it again in rectangular form. All right. See you next time.